Hello everyone. Today we are going to discuss the emulsion part under the course dispersion session. Previously we already discussed the introductory part about the emulsion. Now we are going to see the next point of emulsion, that we say the theory of emulsification, the more important point. Through the point of view examination, the question is always asked on this particular topic. Next, the first, there is a need for theory of emulsification. The theory of the emulsion should be able to explain the stability of product and the type of emulsion which is going to be formed. So the any theory which one is going to be explain the stability and the type of emulsion form, that is come under the theory of emulsification. Simple thing, we say when the two immiscible liquids are mixed together, the one liquid disperse into the another liquid in form of the oil globules, or we say the dispersed phase is come under the droplet or globule size R. And this particular one are not in a stabilized state, in the sense we say that globules are mixed together again and they are getting formed again separate phase is there. So this particular one is get happen because the cohesive forces are greater than adhesive forces. Cohesive forces, the forces between the same particles. Adhesive forces, the forces between the two different types of particles. So here one dispersed phase and the continuous phase, the molecules between this particular forces, cohesive forces we say, which is greater, and that's why the globules come together and they get mixed together again and form the separate phase. So these particular cohesive forces creates the interfacial tension between the two phases are there, or two immiscible liquids are there. The globules are get formed when we mix the two immiscible liquids. They are increasing the effective surface area to the high extent. The globules which are get break from the continuous phase to the small size globules, large size globules are there, the surface area is going to be increased, and this surface area is get measured by using the certain term called specific surface area per unit volume, that shortly termed as SV. This term determines the specific surface area of the dispersed phase per unit volume of dispersed phase. So this one we can calculate by using some formula, that is a SV is equal to 6 divided by dVs. 6 is a numerical factor that we are calculated for the sphere shaped globules are there. So this is a 6 factor divided by dVs. So dVs is a surface volume diameter. So this particular term generally comes under the micrometrics chapter. So that particular one, diameter of the globules, that one we are measuring, that we say is a volume surface diameter, means the unit volume of the dispersed phase creating the spherical shaped globules are there, and what is the certain type of that diameter of the globules, that things we are measuring by using the dVs term. So this effective surface area we calculate 6 divided by dVs if the globules are in a spherical shape. Then the surface area increase, the surface free energy also going to be increased. These things we studied in a suspension initial topics are there, introductory topic are there, where we study the point that interfacial behavior of the suspended particle. In this one we say the surface free energy, that we say the delta G, delta means there is a change in surface free energy, is equal to gamma, that is a interfacial tension between the two different substances are there, multiplied by delta A, means that is a change in a surface area. So these two factors which are affecting to change the surface free energy. Once the surface free energy is going to be increased, then the system is going to be thermodynamically unstable. Thermodynamically unstable, that the certain, we say, the globules are get formed, that globules are going to be merged together again to decrease the change in surface area, and that's why that we say it's a thermodynamically unstable. The emulsifying agents we required here to avoid the mixing of two globules together, that we say the coalescence process are there. So emulsifying agents generally we use causing the interfacial film formations are there, that is a barrier film we say, or they cause decrease in a surface tension. For example, we say the surface active agents are there, they decrease the surface tension. So decrease the surface tension also cause decrease in of surface free energy, and ultimately we obtain the decrease in a surface free energy stabilization of that particular dispersed phase we got. So that is a certain emulsifying agents we use. Which one? Avoiding the coalescence of the globules together, so they are not causing the change in a delta A term, and surface active agents which are causing decrease in interfacial tension, so that's why they are also causing decrease in surface free energy. So the emulsifying agents we need to require to get the certain type of stabilized system, means there is no any coalescence of the oil globules together we observe. So these emulsifying agents generally we say the three different types. The first we say that is a surface active agents which are active on the surface, cause a decrease in interfacial tension of the two immiscible liquids. They are accumulated at the interface and forming the monomolecular film, and this monomolecular film stabilizing the emulsion. Next emulsifying agent is hydrophilic colloid. Hydrophilic colloids, they are the certain we say naturally obtaining, then we say it's animal origin, or that when we say semi-synthetics are there. These hydrophilic colloids are absorbing the moisture and getting swell. They are also present on the interface and forming a certain thick film which is prepared from multimolecular. So that's why it is called as a multimolecular film. Another ingredients or another emulsifying agent that we use that is called as a finely divided solid particles. These solid particles are some specific one which are getting weighted by the certain oil and by some water. So these finely divided solids are adsorbed at the interface and they are forming the certain film. That film is called particulate film, which also cause barrier to get coalescence the two droplets are. So this is a certain one, three different types of emulsifying agents we use to prepare the stabilized emulsion. Next major point that we start, that is a theory of emulsification. So theory of emulsion, that first theory we say the surface tension theory, second theory we say oriented wedge theory, third theory we say interfacial film theory. Interfacial film theory has a certain three different points that we say monomolecular adsorption film, multimolecular adsorption film, and that particulate film. So these films we already seen into the certain previous discussion about the, we say, the emulsifying agents are there. In that one we see this particular one type of the films. Furthermore we get this particular detail. So start the first theory, that surface tension theory. Surface tension theory, that previously we discussed, the small point is there that the interfacial tension is get created because of the cohesive forces, and these cohesive forces causing the more coalescence of the globules that together and forms the separation phase, and this separation phase is not giving the stabilized emulsion. So we say in this particular surface tension theory that it should require the reduce the interfacial tension. So first point we say that whenever the certain oil is get dispersed into the water or any liquid is dispersed into the another liquid, they are forming the spherical shape globules or droplets are there. This sphere shape is get obtained because that sphere has a minimum effective surface area than any other shape is there. First thing. Second thing, that particular cohesive forces are more strong. That's why all the certain particles are getting accumulated into the sphere shape, so that they are not having the more surface area exposed to the other immiscible liquid area. So that sphere shape is get formed, which is the more commonly we obtain, or more things that only say here. So that spherical shape we obtain. Next we say the two or more globules of oil come into contact with this and get joined together, that we say the coalescence process are there, and making the one large drop. This the certain procedure to decrease the surface free energy are there, and that one we already discussed more time. Next we say what are the substances we added into the emulsion that are causing the certain interfacial tension reduce, and that interfacial tension is get reduced, it allow the breaking of the large globules into the smaller one, and this particular one gives the effective formation of emulsion, and that is also get stabilized by these surface active agents are there. So this is a certain we say simple surface tension theory are there, that the agents we use, that agents are acting on the surface and causing the decrease in surface tension. Surface tension is get decreased, the coalescence of the oil globules or the dispersed phase globules are getting decreased, and we got the emulsion formed. Next we say the same thing, we say the surface active agents cause decrease in a repulsion forces between the liquids. So two liquids are repelling each other, that forces are going to be decreased. So that's why the two liquids are getting mixed together, that not actually mix up, but they are getting cause a stabilization of the dispersed phase into the continuous phase. Also, surface active agent cause the decreasing attraction forces between the same molecules, and thus the attraction forces are decreased. There is some interactions between the continuous phase we obtain, and that's why these are getting more stabilized. Second thing we say, the surface active agent facilitates the breaking up of the large globules into the smaller ones, as the large globules, when they get break into the smaller one, the new interfaces are get formed, and these new interfaces are get stabilized by surface active agents. So that's why that particular one cause allowing the larger globules break into the smaller ones. And also, as the interface of the each globules are get stabilized by the surface active agent, so they avoiding the mixing of the two globules together, and thus we say the emulsions are get formed. So this is the first theory. Second theory we say oriented wedge theory. So this particular theory explains how the emulsions are get formed and which type of emulsion is going to be formed. First theory, that we say surface tension theory, doesn't explain much more that which type of the emulsion is going to be formed. They explain how the emulsion is going to be stabilized and get formed. But this theory, first theory, is not explaining the how or which type of the emulsion is going to be formed. Second theory, oriented wedge theory, is going to be explained which type of the emulsion is going to form and how the stability that particular emulsion is going to be get. So the theory assumes the monomolecular film formation of the emulsifying agent at the interface. These monomolecular film is get created or get formed because of certain agents, emulsifying agents we say, which are having the hydrophilic and the hydrophobic the nature within the same molecule, and this particular one gives the specific orientation of the molecules. So hydrophilic part is attached with the water, hydrophobic part is attached with the oil, and that's why they are present at the interface, and this one gives the certain better stabilization of the emulsion prepared. The theory is also based on the solubility of the emulsifying agent and orientation of that particular one agent in a liquid. So solubility means what? This particular one agent, we say that particular has the hydrophilic and hydrophobic nature into the same molecule. If that particular one has a more hydrophilicity, it solubles more into the water. If it has a lipophilicity more, then it's soluble into the oil more. So that's why they are further causing the formation of emulsions, or these things are helpful for the formation of emulsion. So the molecules that will be used as a stabilization purpose, that is called as a surface active agent again. So this particular surface active agent has a polar head and that particular carbon chain which gives the certain type of non-polar chains are there. The phase in which the emulsifying agent is more soluble is become continuous phase, that we already said, that hydrophilic nature more into the emulsifying agent, they are get soluble into the water, and that's why the water is getting become the continuous phase and the oil is become discontinuous phase or dispersed phase. And this particular characteristic of the emulsifying agent which gives the things means that is a which type of emulsion is going to be formed. So if you are using the hydrophilic nature of surfactant or emulsifying agent, then these are forming the O by W emulsion. And if you are using the lipophilic emulsifying agent more, then they are forming W by O emulsion. So this theory explains how that particular emulsion is going to be formed and which type of emulsion is going to be formed. Stabilization of emulsion, that will also we say that the molecules are going to be attached on the interface and they are causing decrease in the interfacial tension. Also they are forming the monomolecular film. That monomolecular film causing the hindrance or barrier to get mixed the two droplets together. So this is summarization of this oriented wedge theory. Interfacial film theory. Interfacial film theory, that's name itself suggests that at the interfacial or at the interface we obtain the film formations are there. And these particular film are going to be formed by the emulsifying agent, as these emulsifying agent when we added, that particular emulsifying agent adsorb at the interface and covers all the globules or droplets of the dispersed phase. And this particular one is forming the thin layer of the film on the surface. This film prevents the mixing of the droplets together, okay? And this particular droplet mixing avoids, means the emulsion is going to be stabilized. Whatever the film is get formed, the films should require some characteristics are there, just like we say the film should be the flexible in nature. So flexible in nature in the sense when we are mixing this one, shake this particular emulsion, that films are get broken or disturbed, and after this particular breaking or disturbing, that again should be get formed rapidly, so that the two globules should not get mixed together and we observe the instability. So this is a certain one characteristic we say that film should be the flexible so that it get reformed rapidly. So these are the certain films are there that when we study under the interfacial film theory. When we prepare the emulsion, first we say the monomolecular film is going to be formed, that we can say the each and every molecule is going to be adsorbed on the interface and only one molecule thick layer that will be observed on the interface are there. So this is called as a monomolecular film. Multimolecular film is another type of film which is also get adsorbed on the interface are there, but the number of molecules are present on the interface and they are forming comparatively monomolecular film. The multimolecular film is a more thick and the more molecules are present into the films are there. So that is called as a multimolecular film. Third film we say is a solid particle film. There is a certain solid substances that will be added which are get weighted partially by oil and partially by water, and these molecules are also get present at the interface, and this particular type of the molecules we observe into the third picture, that molecules arrange themselves on the interface. These are all solid particles and these solid particles create a certain film on the interface, and this particular film is called as a solid particulate film. So these three films we are going to see furthermore under the interfacial film theory of the emulsion. First we go monomolecular film. So monomolecular film maximally we obtain with the certain type of surface active agents are there. So this particular monomolecular film is a flexible film and which is present with a certain surface charge. As we say, the surface active agent has polar head and the non-polar chain. So polar head has some functional group, and these functional group when come in a contact with the water, they get partially dissociated and they are causing the certain charge formation. When the polar head has a charge, this charge additionally gives the certain stability to the emulsion form in form of the certain potential get created. So potential that we say it's a zeta potential and the nurse potential. So the surface is getting charged because of this particular surface active agents are present on the interface, and this particular one causing repulsion between the two different oil globules are there. And this particular repulsion given the more stability along with the flexible films are there. The films also giving the certain type of we can say resistance to get mixed these two globules together, and these two things given the more stability for the emulsions through the monomolecular film formation. So emulsion form is depends on the solubility of emulsifying agent that we already discussed here. So solubility of emulsifying agent is more important. In which phase the emulsifying agents are get solubilized, that particular one phase is become continuous phase. Means for example we say any hydrophilic surfactant, for example we say the twin surfactants are there that we added that is more hydrophilic, so that's why they are causing the aqueous as a continuous phase, and oil is going to be in a disperse phase. So here we say if you are using a hydrophilic emulsifying agent, then that particular emulsifying agent forming the O by W type of emulsion, and vice versa. If you are using the lipophilic emulsifying agent, they are forming the W by O type of emulsion. So this we can say up till now that is a certain monomolecular film that we are saying, but that is the simplest film that we say. Simplest film means what? There is only one surfactant we use, and that is going to be form the complex film. That is form the simple film. Now we are going to see the complex film area. Complex film is what? Here instead of one surfactant or only one emulsifying agent, we use here the combination of different emulsifying agents are there. Combination we use for the 2, 3 or number of different types of emulsifying agent we use mixed together, they are forming more complex films are there. These complex films are also monomolecular films are there, and because of the complexations are between the emulsifying agents are there, we got more stability for the interface are there. So this complex film is what? We use a combination of hydrophilic emulsifying agent and hydrophobic emulsifying agent. That particular proportions we mix these two different types of emulsifying agents, and these proportions gives the more stability of the interface are there. Ultimately we get more stable emulsions are there. So these two hydrophilic and hydrophobic emulsifying agents form the complex film at the interface and gives the certain film rigid, flexible, that all characteristics we obtain in a complex film are. So whatever the certain type of emulsion is get produced, it depends on primarily on the property of emulsifying agent that we say it's a HLB number. Hydrophilic lipophilic balance, that particular one term we already discussed in a previous sessions are there. So hydrophilic lipophilic balance, that is a HLB value we obtain for each surfactants are there. Emulsifying agents, that when we mix in a certain proportion, from that particular proportion we can get the certain type of HLB value of the mixture of that emulsifying agents are there. And if that particular one emulsifying agent mixture HLB values are in a certain number, then we obtain a certain different types of emulsion. Simply we say the HLB gives the polar non-polar nature of the emulsifier. How much polar is there, how much non-polar part is there, that things we are obtaining by using HLB number. The rule of Bancroft gives which type of the emulsion is going to be formed when the when the HLB value of the mixing two emulsifying agents that we obtain, that particular one we say rule of Bancroft. Means what? We use a certain number of different types of emulsifying agent together to form the complex film. When we mix that particular number of emulsifying agent together in a certain proportion, by calculations of that particular proportion and the HLB values, we got the HLB value of mixture. And this HLB value of mixture, if it is in a range of 9 to 12, that particular one gives the more hydrophilicity to that particular mixture, and because of more hydrophilicity, they are forming O by W emulsion. Next we say, if that particular mixture has a more lipophilicity, means the mixture of that particular emulsion has a HLB in range of 3 to 6, means there is a more lipophilicity is present, and this particular lipophilicity forms the W by O type of emulsion. So this particular thing is explained by the rule of Bancroft. So rule of Bancroft is a more one point measure which are more important for the formation of emulsion. Interfacial film theory. Interfacial film theory, that's name itself suggests that at the interfacial or at the interface we obtain the film formations are there. And these particular film are going to be formed by the emulsifying agent, as these emulsifying agent, when we added that particular emulsifying agent, adsorb at the interface and covers all the globules or droplets of the dispersed phase. And this particular one is forming the thin layer of the film on the surface. This film prevents the mixing of the droplets together, okay? And this particular droplet mixing avoids, means the emulsion is going to be stabilized. Whatever the film is get formed, the films should require some characteristics are there, just like we say the film should be the flexible in nature. So flexible in nature in the sense, when we are mixing this one, shake this particular emulsion, that films are get broken or disturbed, and after this particular breaking or disturbing, that again should be get formed rapidly, so that the two globules should not get mixed together and we observe the instability. So this is a certain one characteristic we say, that film should be the flexible so that it get reformed rapidly. Another example we take in case of the complex film, where we use a certain two different types of surfactants, which are the hydrophilic and the lipophilic. Here we mix the twin hydrophilic surfactant and the certain span lipophilic surfactant. The typical example we take here, the twin 40, which is a polyoxyethylene sorbiton monopalmitate, and span 80, that is a sorbiton monooleate. So span 80 is a sorbiton monooleate. That structure we observed in the image, that oil phase, that interface they are showing, oil is in a global form, water is in a continuous phase, and these particular molecules are getting present at the interface. So sorbiton molecule that when we use, or the span 80 molecule we are using, which has a sorbiton head. This sorbiton head is a bulky, and this particular bulky head is not causing the attachments of the certain long polymeric chain that we can say which is present into the oil phase are there, which is a lipophilic in nature more, and these chains are not get mixed together or not get attached together, and that's why that particular one is given the more complex films are there. Along with this one, we say that twin 40 that we are mixing with the span 80 is there. So the molecular arrangement we obtain in between the two span, there is a one twin molecule is present. The oil chains, or that particular we say the fatty acid chains, in case of twin that is a palmitic acid, and in case of span there is a oleic acid. These fatty acid chains are present in the oil side, and these fatty acid chains are creating very small van der Waals forces of attraction, and because of that one they are getting firmly attached inside the oil globules. And whatever the certain we can say the sorbiton head present on the interface in a water phase or in aqueous side, these sorbiton heads are getting repulsion between the oil globules are there. So the twin has a polyoxyethylene chains are there. These are causing the steric hindrance, and the certain sorbiton here the radical is a sorbiton radical, which one causing repulsion also, and they are not allowing to mix the two hydrocarbon chains of the oleic acid together. So this is a certain one complex film has get formed by mixing the twin and span molecules are there, twin and span surfactant molecules are there, and they are stabilizing the emulsion by this way. Next we say the multimolecular adsorption film. Multimolecular adsorption film is get prepared by the hydrated lyophilic colloids. Lyophilic, here we say the water molecules are going to be more loving by this particular type of colloids are there. So hydrophilic colloids generally we use, and these hydrophilic colloids are forming the multimolecular film. Multimolecular films, they are thick films are there and present on the interface. They get differ from the surface active agent, as they are not causing decrease in interfacial tension anymore, and also they are not forming the single molecule thick film on the interface. They are forming multimolecular, means more number of molecules are present on the surface. Along with this one, these films are the strong in nature, and they are also avoiding coalescence between the different droplets are there. The stability of emulsion is get increased with increase in viscosity. So this particular one we observe additional effect or additional stability effect we obtain in case of hydrophilic colloids. As these colloids are get mixed into the water, they are increasing the in viscosity. As they are increasing in viscosity, they also create the certain less coalescence of the droplets are there. So this is additional benefits we obtain when we use a hydrophilic colloid, as they are forming multimolecular film and also increasing the viscosity. Hydrophilic colloids maximally forming the O by W emulsions, as they are having the more interactive with the water molecules are there. They are the hydrophilic in nature, that's why they are forming only O by W type of emulsion. W by O type of emulsions are very few are getting formed by using this particular type of colloids are there. Some hydrophilic agents we say that is a we can say naturally obtaining animal source and the plant source we can say. From the plant we get the certain type of the acacia, tragacanth, agar, pectin. These are the certain types of vegetable or plant sources we get the certain hydrophilic colloids. Animal sources we get the certain gelatin, then we get the certain cholesterol, lecithin. These are the certain type of molecules we obtain from animals are there. Synthetic, before synthetic we go for the semi-synthetics are there. So cellulose derivatives are getting the some reactions, they are getting attached to some molecules are there, and that particular one is getting formed methyl cellulose, carboxymethyl cellulose, hydroxymethyl cellulose, HPMCs are there. So these are the certain types of molecules going to be formed, and these molecules also act as a hydrophilic colloids. Synthetic one, they are having the certain type of PEG and acrylic acid derivatives. Carbomers are there. These particular agents are the hydrophilic in nature, and they are used as a emulsifying agents. They are also forming the multimolecular films are there. So this we can say up till now that is a certain monomolecular film that we are saying, but that is the simplest film that we say. Simplest film means what? There is only one surfactant we use, and that is going to be form the complex film. That is form the simple film. Now we are going to see the complex film area. Complex film is what? Here instead of one surfactant or only one emulsifying agent, we use here the combination of different emulsifying agents are there. Combination we use for the 2, 3 or number of different types of emulsifying agent we use mixed together, they are forming more complex films are there. These complex films are also monomolecular films are there, and because of the complexations are between the emulsifying agents are there, we got more stability for the interface are there. So this complex film is what we use a combination of hydrophilic emulsifying agent and hydrophobic emulsifying agent. That particular proportions we mix these two different types of emulsifying agents. And these proportions gives the more stability of the interface are there. Ultimately, we get more stable emulsions are there. So these two hydrophilic and hydrophobic emulsifying agents form the complex film at the interface and gives the certain film rigid, flexible, that all characteristics we obtain in a complex film saga. So whatever the certain type of emulsion is get produced, it depends on primarily on the property of emulsifying agent that we say it's a HLB number. So these are the all theories for the emulsion formations are there. Three different theories, more important. The question is always asked in your examination. So prepared well and get the certain study well. Here we stop the theory of emulsification. Thank you.